Today we're going to take a look at the trig ratios on the unit circle. So today we're going to be considering sine, cosine, and tangent, and then tomorrow we'll do all of them. So first thing to know, we're going to be learning and memorizing all of the trig ratios at all of the special angles on the unit circle. These are all the 35 degrees, 45 degrees, 60 degree angles, plus the angles that lie on the axes themselves. So the key to this is knowing that, and I hate that this got so tiny. When I made this, it wasn't supposed to be that tiny, but that the x-coordinate of every point on this unit circle is your cosine of theta, and the y-coordinate is your sine of theta. So x is cosine, y is sine. I need you to remember that. Okay? Alright, let me go back to this. Alrighty. So, if that is true, and it is, okay, what is sine of 0? And I'm talking all radians here. Today, all radians. Okay. Sine of 0 radians. Well, 0 is right here. 0 radians is right here. What is sine is the y-coordinate. What is the y-coordinate of that point? This is the point 1, 0. So what is the y-coordinate? It is 0. So sine of 0 is 0. Cosine of 0 is 1. That's the x-coordinate. Sine of pi over 2. Well, here's pi over 2. The point is 0, 1. So sine of pi over 2 is the y-coordinate, 1. Cosine of pi over 2 is the x-coordinate, 0. Go to pi. Sine of pi, the y-coordinate, is 0. The x-coordinate is negative 1. So cosine of pi is negative 1. Sine of pi is 0. Let's go to 3 pi over 2. The y-coordinate, sine of 3 pi over 2, is negative 1. The x-coordinate, cosine of 3 pi over 2, is 0. Let's go to 2 pi. Well, that is the same thing as 0. So these are all going to start repeating as we go around and around and around and around. So sine of 2 pi is the same as sine of 0, and that is 0. Cosine of 2 pi is the same as cosine of 0, and that is 1, the x-coordinate. So anytime you're on an axis, you go to your points on the unit circle. It's one way to do it. Okay? Alright, let's examine the pi over 4 angle. Okay, I'm going to draw the pi over 4 angle. Where's my little... I lost it. Oh, it's under here. Okay, a little straight edge. I'm going to draw the pi over 4 angle here. Okay, there's the... You can hardly see it. Let me draw it a little bit off here. There we go, that's better. Barely see it. Okay, there's the pi over 4 angle. What I want to do is write the x and the y coordinate for this point that's on the unit circle. So I'm going to drop my perpendicular here to the x-axis like we were doing yesterday, or at some point before Thanksgiving break this year. Okay, there's my perpendicular. Now this is a unit circle, which means that every radius is 1. So these legs are less than 1. How big are they? Well, this is a 45, 45, 90 right triangle. And the ratio is 1, 1 square root of 2. So if this is 1, then this must be 1 over square root of 2, which is square root 2 over 2. So this point is square root 2 over 2, square root 2 over 2. Therefore, sine of pi over 4 is the y-coordinate, that is square root 2 over 2. Cosine of pi over 4, is also square root 2 over 2. They are identical. At the pi over 4, they are identical. Okay? Pi over 4. Alrighty? Now, what about the pi over 4 angles in the other quadrants? Well, I'm not going to go and do this triangle in all the quadrants. What I'm going to do is use what we already know about the sines. All the trig functions are positive in quadrant 1. Only sine is positive in quadrant 2. Only tangent is positive in quadrant 3. And only cosine is positive in quadrant 4. So sine of 3 pi over 4, which is in quadrant 2, is positive square root 2 over 2. Same value, we just need to examine, is it positive or negative? Cosine in quadrant 2 is negative, so negative square root 2 over 2. Quadrant 3, both sine and cosine will be negative, so negative square root 2 over 2, negative square root 2 over 2. Quadrant 4, only cosine is positive, so sine of 7 pi over 4 will be negative square root 2 over 2, while cosine of 7 pi over 4 is positive square root 2 over 2. What about tangent? So tangent. Since tangent is opposite over adjacent, that makes tangent always, tangent of any angle is always sine of that angle divided by cosine of that angle. Always. So what is sine of pi over 4 divided by cosine of pi over 4? Well, sine of pi over 4 is square root 2 over 2. Cosine of pi over 4 is square root 2 over 2. So tangent of pi over 4 is 1. So tangent of pi over 4 is 1. 7 pi over 4 is in quadrant 4. Tangent is negative there. So negative 1. Let's do the same thing for the pi over 3 angles. So here are the pi over 3 angles. Well, here is the pi over 3 angle in quadrant 1. I hate that that is not showing up very well on this video, but there it is. Okay, I'm going to once again drop this perpendicular to the x-axis, make a triangle, make a right triangle. Okay, there's my right angle. The hypotenuse is still length 1 because it's a unit circle. That's length 1. Okay, so this is another special right triangle. 30, 30, 60, 90 right triangle. And their sides, if you remember from geometry, their sides are also in a ratio. This ratio is 1, 2, square root 3. 1, 2, square root 3. So if this side is 1, this shorter side has to be 1/2. Must be. If this is a 30, 60, 90 right triangle, it has to be half of the hypotenuse. This side has to be square root 3 over 2 then. For it to be in the right ratio, 1, 2, square root 3, it has to be like that. So this point is the x-coordinate is 1/2, the y-coordinate is square root 3 over 2, and remember, x-coordinate is cosine, y-coordinate is sine, always. So sine of pi over 3 is square root 3 over 2. Cosine of pi over 3, 1/2. Okay, now that we know those, these are the two that you need to memorize. Then we're going to use all students take calculus to do the other quadrants. As soon as I see I'm looking at a pi over 3 angle, all I have to do is look at the quadrant. I know sine of any pi over 3 angle is 3 pi over 2. All I need to do is determine if it's positive or negative. Okay? So sine of, I know that I'm going to have a square root 3 over 2. Is it positive or negative? Well, this angle is in quadrant 2, where sine is positive. Cosine of every pi over 3 angle is a half. In quadrant 2, negative 1/2. As soon as I see I have a pi over 3, I know cosine is going to be a half. All I have to do is determine the sine. Sine of 4 pi over 3, that's in quadrant 3. Sine is negative there. It's a pi over 3, so I know sine is square root 3 over 2. Cosine is also negative in that quadrant, so negative 1/2. 5 pi over 3, fourth quadrant. Sine is negative in the fourth quadrant. It's a pi over 3, so square root 3 over 2 for sine. Cosine is positive in that quadrant, so positive 1/2. Tangent. So tangent of pi over 3 is sine of pi over 3 divided by cosine of pi over 3. Well, sine of pi over 3 is square root 3 over 2. Cosine of pi over 3 is 1/2. If I multiply top and bottom by 2, I get square root 3 over 1, which is square root 3. Tangent of square root of pi over 3 is square root 3, period. Which quadrant is 2 pi over 3 in? It's in quadrant 2, where tangent is negative, so negative square root 3. Let's do the pi over 6 angle. Here's the pi over 6 angle. Still not showing up. Okay, do the same thing we have been doing. Form our little right triangle, the x-axis. There's our right angle. The hypotenuse is still of length 1 because it's a unit circle. And we still have this 30, 60, 90 right triangle. Where's the 1/2? Well, the 1/2 is right here. What does that make this length? Square root 3 over 2. So the x-coordinate is square root 3 over 2. The y-coordinate is a half. And once again, cosine of pi over 6 is the x-coordinate. Sine of pi over 6 is the y-coordinate. So this time, sine is a half. Cosine is square root 3 over 2. I think of these as pairs. These pairs. 1/2 and square root 3 over 2. Kind of buds. They like to go together. Okay? Second quadrant. Sine is positive. Second quadrant. Cosine is negative. Third quadrant. Sine is negative. Cosine is negative. Fourth quadrant. Sine is negative in the fourth quadrant. Cosine is positive in the fourth quadrant. Okay, tangent. Sine over cosine. So this will be sine of pi over 6 divided by cosine of pi over 6. Well, sine of pi over 6 is a half. Cosine of pi over 6 is square root 3 over 2. Multiply top and bottom by 2, and we get 1 over square root 3, which is square root 3 over 3. Square root 3 over 3. In the second quadrant, this is in the second quadrant, 5 pi over 6 is in the second quadrant. Tangent is negative, so negative square root 3 over 3. Alrighty. That was a bit, but those all go together. Okay, let's write all of these without using the entire unit circle. Okay? I'm going to talk about the ways that I remember these. Okay? Sine of pi over 6. This is truly the one I memorize. I memorize sine of pi over 6, and it is 1/2. I memorize it. You guys can memorize one trig function. Memorize that one. Sine of pi over 6 is 1/2, period. The pi over 6 angles and the pi over 3 angles go together. They go together. They're buds. Okay? What goes with 1/2? If sine of pi over 6 is 1/2, what is sine of pi over 3? Square root 3 over 2. They go together. They're paired. Okay? If sine of pi over 6 is 1/2, what is cosine of pi over 6? Cosine of pi over 6 is the bud. It's the square root 3 over 2. Cosine of pi over 3, 1/2. Okay? If I know these, or can get these, then I can go to any quadrant and just use my signs. All I do is memorize this one, and I know that square root 3 over 2 goes with it. Okay, for tangent of pi over 3 and pi over 6, here's how I memorize this. Pi over 3 has 1/3. Correct? Pi over 3 has 1/3. Tangent of pi over 3 has 1/3 then. Square root 3. 1/3, 1/3. Pi over 6. 6 is 2 3s. So tangent of pi over 6 is square root 3 over 3. 2 3s. 2 3s make 6. Okay? That's how I memorize those. Pi over 4s. The pi over 4s. Sine of pi over 4, square root 2 over 2. 2 plus 2 is 4. Cosine of pi over 4 is the exact same thing. The sides are the same in a 45, 45, 90 right triangle. The legs are the same, so the sine and cosine must be the same. Since they are the same, tangent will be 1, because sine over cosine is 1. So you see, the only one that I really memorize is this one. The other ones fall into place if you know how they all related in the first place. Okay, so let's do some. Okay, you'll notice whenever I'm starting out, I will always ask you, what is sine of pi over 6? That's always going to be the first thing I ask you. What is sine of pi over 6? Sine of pi over 6 is 1/2. That's the one we memorize. Okay? All right. Cosine of 2 pi over 3. Well, 2 pi over 3 is in quadrant 2. Why is it in quadrant 2? 3 pi over 3, 1 less. 1 pi over 3 less than 3 pi over 3 is it right here, quadrant 2, where cosine is negative. Okay? All right, pi over 3. Cosine of every pi over 3 angle is 1/2. So, sine of pi over 6 is 1/2. Therefore, cosine of pi over 3 is 1/2. Okay? So, the cosine of 2 pi over 3, negative 1/2. Tangent of a pi over 4. Well, it is a pi over 4. First of all, it's a pi over 4. I can't reduce 7 pi over 3, so it's a pi over 4. Tangent of pi over 4 is 1. Now I just need to know, is it positive or negative? So what quadrant is 7 pi over 4 in? 7 pi over 4 is 1 less than 8 pi over 4, so we're down here in quadrant 4, where tangent is negative. So this is -1. Okay? Sine of 5 pi over 3. Well, first of all, it's a pi over 3. Sine of pi over 6 is 1/2, so sine of pi over 3 is square root 3 over 2. Now I just need to deal with the sine. What quadrant is this in? Well, 5 pi over 3 is 1 less than 6 pi over 3, so we are down here in quadrant 4, where sine is negative. So this will be a negative square root 3 over 2. Cosine, pi over 2. We are on an axis. 3 pi over 2 is right here. What is that point? That point is 0, -1. And cosine is the x-coordinate 0. Tangent of 5 pi over 6. Okay, it's a pi over 6. Tangent of a pi over 6, 6 has 2 3's, square root 3 over 3. What quadrant are we in? 5 pi over 6 is 1 less than 6 pi over 6, so we are in quadrant 2 where tangent is negative. So this will be a negative square root 3 over 3. Sine of 3 pi over 4. Well, it's a pi over 4. Sine of a pi over 4, square root 2 over 2. What quadrant are we in? 3 pi over 4 is 1 pi over 4 less than 4 pi over 4. So we're in quadrant 2 where sine is positive. So this is just a positive square root 2 over 2. Cosine of 11 pi over 6. Pi over 6 is where sine is a half. So cosine of a pi over 6 is square root 3 over 2. Okay, now we get the sine. What quadrant are we in? 11 pi over 6 is very close to 12 pi over 6. So we're in quadrant 4 where cosine is positive. So this is a positive square root 3 over 2. Last one, tangent of a pi over 3. Tangent pi over 3, single 3, single 3. And now 4 pi over 3. 4 pi over 3 is a little more than 3 pi over 3, so we are in quadrant 3 where tangent is positive, so a positive square root 3. Before I leave you, I want to show you one more thing. One more way, if you're looking for a way to memorize these angles in the first quadrant. There's the 45-degree angle pi over 4. Here's a little bit shorter, that's the pi over 6. And here's a little bit bigger, that's the pi over 3. Okay, these points. Okay, here's another way that you can easily get these points. All right, on the outside, the y-coordinate. Start with 1 over 2. Then go to 2 over 2. Then go to 3 over 2. And then take the square root of each numerator. Square root of 1 is 1. Square root of 2, square root of 3. That gives you the y-coordinates. Those are the sine of each one. Okay, so sine of pi over 6 is a half. Sine of pi over 4, square root of 2 over 2. Sine of pi over 3, like that. If you want the cosines, you go backwards. You start at 1 over 2, 2 over 2, 3 over 2, and then do your square roots, and that gives you your cosines. But honestly, I don't do it like that. I don't memorize those. Like I said before, I do sine of pi over 6, and I know that's 1/2. if I know that's 1/2, I can get to the other ones. Alrighty? So that's it. That was our trig ratios on the unit circle.